Okay, part 2 of chapter 9 is looking at how organisms can be transmitted from one host to another, and that's going to be referred to as the mode of transmission. All right, how does the pathogen spread? And there are two major categories: direct contact and indirect contact. The direct contact is what you might think. It's person to person. It is animal to person. It can be environmental. It can be vertical, meaning it goes from mother to child. And usually this refers to in utero or vaginal delivery, and then also through breast milk. With direct contact, it is direct contact between the source and then the potential host. And you can think of a variety of ways that this can occur. You've got examples there. With the environmental, here the pathogen resides in an environmental source, and so a lot of times, especially during the summer, different pools of water, whether that be lakes or hot springs or water reservoirs, are often cut off to human use because they're found to contain different types of organisms. That can be bacteria, that can be algae, that can be protozoa, that can be problematic if humans come into contact with it. And then that pathogen makes its way into the human body. All right, indirect contact transmission, just as common as direct contact methods. Airborne, so respiratory aerosols here. Wind. Wind is a major spreader of histoplasmosis. This is a fungal organism, and in areas in California, maybe New Mexico, Arizona, there is, where they may have some major windstorms or dust storms. All right, that histoplasmosis resides in the environment, and during those major dust storms, windstorms, all of that can get kicked up and spread and put into the air, and people can breathe that in, and it can cause disease. And there are instances where that can actually be tracked. All right, vehicle transmission. All right, the pathogen is introduced to a host through contact with contaminated objects. And what you're shown here is a needle, but it can be food, it can be contaminated water, that the organism is basically hitching a ride with some other material. Then there's a vector, and the vector is going to be a live material that transfers the organism. And if it's a biological vector, then that means the pathogen lives inside, has part of its life cycle that occurs within the organism. And there's a lot of diseases that are caused or transmitted in this method. You've got mosquito bites that will transmit malaria, yellow fever, tick bites, flea bites that transmit other bacterial diseases. All right, and then vector, if it's mechanical, then the pathogen just hitches a ride. So you've got the fly here, you've got cockroaches as examples, where they grab the organism, say on their legs, on their feet, if they have little feet, and they fly from one place to the next. And if a fly lands on your food, if you have it out in the open, then that bacteria, that pathogen, can be deposited onto the food, and then you eat that and you consume that organism. All right, so talked about this on the last slide, just additional information. The direct contact, the host comes into physical contact with the source of the pathogen. And then vertical transmission, this is a specialized form of direct contact because it passes from mother to offspring. And it has those 3 time periods with pregnancy, delivery, and breastfeeding. Once a pathogen makes contact with the host, the goal is to establish infection. And there are a couple of words or terms used when describing the ability of an organism to cause infection. one of them is infectivity. All right, how good does an infectious agent, how good is it at establishing an infection? If the organism gets put on my skin, how well can that penetrate my skin in order to cause disease? All right, or does that organism have to be deposited on broken skin, a scratch, a wound? All right, then virulence describes the severity of a disease following infection. How virulent is the organism in its ability to cause disease? Is it just a rather superficial infection due to that organism, or is it potentially life-threatening? And then pathogenicity is the general ability of an infectious agent to cause disease. All right, somewhat similar to virulence, is an organism pathogenic? Can it cause disease? And is it, if it can cause disease, how severe is it? Is it just pretty minor? Or, can you take oral antibiotics for 7 to 10 days? Or do you actually need to get admitted to a hospital and have IV antibiotics to actually, keep you alive, because that's how pathogenic the organism is. All right, now if you do come down with a disease caused by a microorganism, there are 5 stages of the infection. And sometimes it's referred to as the infection, sometimes it's referred to as the stages of disease. But it's all the same for the most part. All right, you've got the incubation period, the time between infection and the development of the earliest symptoms. This can be quite different based on the microorganism you're talking about. Is it bacteria? Is it staph versus TB? All right, if you remember from the bacterial growth chapter, a lot of bacteria have an average generation time of 20 to 30 minutes, so it can replicate quite quickly. But if you come down with the organism, get exposed to the organism that causes tuberculosis, that organism has a generation time of anywhere from 18 to 36 hours. So that incubation period can be quite lengthy, can be quite different. Then there's the prodromal phase, early symptoms develop. This is like when you're getting a cold and you get that tickle in the back of your throat, a dry throat, a scratchy throat, and you think, I think I might be getting sick. That's the prodromal phase. And then you have the acute phase, which is basically the peak of the disease. And this is where the pathogen count, the amount of pathogen in your body, is increasing substantially, and it peaks. And then you have a period of decline where at this point the infectious agent is basically brought under control because of your immune response, your body's response to the infection, and the symptoms start to resolve, pathogen levels go down, and then you have this convalescent phase where the patient recovers. And in some cases, the pathogen is kept there at low numbers. All right, maybe the pathogen goes latent, like chickenpox, herpes virus, varicella zoster, where if you have chickenpox, normally, in almost every case, you survive and the virus goes away. You clear all of the signs and symptoms, excuse me. But unfortunately, that virus remains latent in your body, and so there's always the potential for that virus to come back out and start growing again, and basically repeating this process. All right, so in some cases you can also have asymptomatic cases where the symptoms are very mild or even non-existent, and so you may not actually know that you are sick, or that prodromal phase, the prodromal and acute phase, you may not know that anything's going on, but rather you are still infectious. And so here are some diseases where there are subclinical cases, basically asymptomatic. Polio, all right, not that many people have polio now, but prior to the vaccine, It was estimated that almost all kids were exposed to polio and that most were asymptomatic. Their body just cleared it without it becoming a problem. And then there's Epstein-Barr virus. Goodness, sorry. That causes mono. And nearly all individuals are seropositive. Right? They have been exposed to the virus, but not very many people actually get mono. And then you can see the other infections down here, and most of this is going to be cases of viral infections. All right, then with epidemiology, this is the study of what is upon people. All right, if you look at the where the root of that word came from, and it focuses on diseases, both infectious and non-infectious, and then aims to understand and prevent illnesses. So the two general goals of epidemiology, which are two of your specific objectives, describe the nature, cause, and extent of new or existing diseases in population, and then to intervene and protect and improve health within the population. All right, so there's the epidemiological triangle, looking at the host, the etiological agent, where is that disease coming from, and the environment. And so you've got this triangle basically right in here, where you have disease, where you have the correct scenario of host factors, the agent, and then environmental factors that all come together to basically create this perfect storm where disease can be established. All right, host factors, overall health, gender, lifestyle, your age, ethnicity. There are different ethnic groups that are more susceptible because of genetics to different diseases. What your occupation is might depend on what you're actually exposed to down here. All right, do you basically work in isolation? Do you work from home with a computer and a phone most of the day? Or are you a healthcare provider and you're actually interacting with a lot of fungal, bacterial, viral, or parasitic items every day? All right, so there's a lot of different scenarios that come into place, which is why two people might be exposed to the same organism, but only one person gets sick, because there are these different, it has to be a particular combination of scenarios and events. All right, so an infectious disease might be barely noticeable in a normally healthy host, but could actually kill an immunocompromised patient. I mentioned that in the first video, where if a person came down with a particular fungal infection or were exposed to a fungal organism, if you are immunocompetent, then your body's probably going to clear it. But if you are immunocompromised, if your immune system is not functioning properly, then you could actually be at risk for coming down with that infection. All right, those who are at risk are babies, because their immune system isn't functioning properly, it hasn't matured. The elderly, because their immune system as well as their overall health is actually deteriorating some. And then organ transplant recipients and a lot of other people with chronic diseases, that such as, rheumatoid arthritis or inflammatory bowel disease, that are actually on medications to dampen the immune response. Right? For organ transplant recipients, their immune system is specifically told not to react so stringently, because the doctors don't want that organ to be attacked by that recipient's immune system. All right, and then the last slide for this part, looking at the frequency of disease, you can look at the population, which is any defined group of people. Are you looking at a particular county, a country, a continent? And then morbidity is the existence of disease in a population. How high is the disease within that population? And then prevalence is the morbidity within a given population at a specific time. Is it the last 2 months scenario?